Yeah, I recorded. Great. And maybe Valeria can also write a message into the chat in Ukrainian, just explaining the translation. Yeah, but he's not here this time. Yeah, sorry. Oh yeah, yeah. I think so. Good, yeah. But we should. Mhm. I see. But we should stay on this channel, right? Me and Martin. Yeah. Thank you. Oops. Okay, so it's already 9 o'clock. So let's maybe wait a minute or two. Hello, everyone. Welcome. Доброго дня. My name is Eva. I'm from Habitat for Humanity. It's one of the organizers of this training here. I think we'll just give this a few more minutes. I see that there's still a few people trying to connect. In the meantime, should you wish, please just write into the chat if you want to introduce yourselves and tell us from which municipalities or which regions you're coming from. We'll be happy to learn a little bit more about you. And I see some of you have been already present in the previous meeting, so I'm happy to see some familiar names. All right, there's still one person trying to connect. So but maybe in the meantime, yeah, it's almost 10 or 5. So in the meantime, maybe I can just start slowly with the kickoff. So as I said, good morning, everyone. I think that you've already heard this introduction, maybe some of you a few times, so I'll try to be very quick. But for those who are joining us for the first time, I just would like to give you a short introduction of who we are and why we are organizing these courses. Yeah. So I come from Habitat for Humanity. It's a humanitarian organization focused on affordable housing. The organization has over 50 years of the tradition. We are also present in Ukraine, and currently the organization already supported over 3,000 dwellings. in the reconstruction process. But Habitat is a part of a bigger consortium of organizations, a project called Smarter for EU. It's a project financed by the European Commission from the LIFE funding. And since May of this year, Habitat and 9 other colleagues or colleague organizations, including present Association for Energy Efficient Cities for Ukraine, we cooperate together in a project focused mainly on green housing, green certification, green mortgages. Just to very simply introduce what we are actually doing, that the project is trying to be the middle link between the banks and developers, and make it possible for these two stakeholders to create agreements about new housing projects which would be highly energy efficient, highly green. What we are bringing to the table is the know-how of green certification. So this project actually has goes way back into 2019, where we've implemented the first part of Smarter. So currently we are a group of about 20 organizations, mainly green building councils from all over the Europe. And we developed this green certification, which we are now offering to developers and the banks in order to help them to create new funding products which would fund their green development projects. We have a special part of this project focused on vulnerable families and low-income households. And as a part of this part of the project, we do this is the reason why we are offering these courses for municipalities, because a part of our project is this focused on developers of green housing for vulnerable families. So we do see, especially the municipalities and local NGOs and local initiatives, a key component and a key partner for us when it comes to support of low-income housing in this green quality. So without the further ado, I would like to jump into the focus of today's course. So today it's actually a really interesting topic. We would like to talk about sustainable site selection and management. Actually, when I started to learn a little bit more about the topic of green housing, it didn't even occur to me, or it's not just about the building itself, but also the building sites and what's going on during the process is a part of what we call a green building. So I think that it will be quite interesting and maybe quite challenging topic for us, which will teach us kind of how far we can go when we are talking about what is a green building and how far from the building we can go, and so what is the surrounding which affects that's the result is really going to be green. We have here today a very distinguished guest, Martin Dreiseitel.
Just Martin, that's a little bit shorter.
Yeah.
And easier.
Martin is a president and CEO of F&R Worldwide. He has over 20 years of experience with sustainable site selection and development. He was actively involved with many projects in Romania, Western Balkans, Estonia. And I also believe that he's got extensive knowledge of brownfield strategies and working on ideas of how to develop green buildings in brownfields. So Martin's course is third in our series. We still are hoping to have 2 more, which are going to happen this month, and we are planning for 3 another courses. So there's still a lot to come, and hopefully, and this is the last words from me. This is just the start. These courses for smarter and our focus for vulnerable families. The project is a 2-year project, so we are really hoping that after these courses, we will have a chance to have some more individual conversations with some of you, and with municipalities interested to maybe get a free consultations on their green project. So we would really like to stress that this is our way how we are trying to start a conversation on a much needed recovery of Ukraine together with partners at the local level. So this is it from me, and enjoy this course.
Thank you, Eva, for the introduction. Yeah, welcome to everybody. I'm really impressed how many people are participating to the course. I'm doing this course now already for 12 years, and that's definitely so far the biggest course we ever had in different countries. We did it in Montenegro, we have been to Croatia, we have been to Estonia, we've been to Latvia, and of course in Romania, where it all started. So that's really cool, and thank you for having me. Eva already gave a little background of myself. So by training, I'm an environmental engineer, passionate about what I'm doing, and I'm doing this now for 26 years. And especially the green building part is extremely important to me. And I want to share with you what I learned over the last years, and I hope you enjoy the course and you take something with you, and feel free to ask questions. Luckily, we have an interpreter because my Ukrainian is on level 0. I managed to learn Romanian over the years, but yeah, I hope you apologize. Ukrainian I have not picked up so far. Just interrupt me, ask questions where you want more information. We will manage this. We have 3 hours together. If you think it's going too fast or too slow, you can tell me. If you need a break, you can tell me. Yeah, and maybe, I'm not sure how it will work or if it will work. Maybe we can make it a little bit interactive so that I'm not just talking alone for 3 hours. But let's see, no obligation, just relax. Sit back and relax, and yeah, enjoy the show. Eva, thank you very much for addressing this starting point. Whenever people think green building, as the words already indicates, they focus a lot on the building. And there are very few people who are seeing it a little bit bigger and actually, where do I put my building? And you will hear today more or almost only about the site and how to pick the site and how to manage the site and how this falls into this whole picture of green building. So to become a green building professional, you really, I think you need to understand the aspect of the site as well. You don't have to become experts, but I think you should understand what is behind, and when you are talking to somebody, that you can easily tell, is he telling me just a story, or is it true? Does this person understand what he's talking about? Then let's start. I want to make sure, because I don't know what you're doing, what your background is, where you're coming from, if you're, I don't know, an architect, if you're an engineer, if you're from an authority. I don't have this information, and I just want to make sure at the beginning that we all talk about the same thing and kind of reach a little bit a similar level of understanding of the terms and the definitions we will use today. So the first word is sustainability. So what's sustainability? it's commonly used. It's a very popular word, but it's important that we really talk the same language. And I think one of the most widely used definition is coming from the United Nations Commission. They issued a report many, many years ago, and this is what they said is sustainability. So they're talking about a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So what does this mean? This sounds very fancy, but what's actually the spirit behind? We are, I like to call it, we are renting the earth for a period of time, us, our generation, and then we will hand it over to the next generation. So whatever we decide today has an impact not only on us, but has an impact also on the future generations. And this idea of sustainability is mainly okay, because we can't call them to the table most of the times. They don't exist yet. So we have to think on their behalf. So whatever we do, we should wisely analyze and decide how we will do things. And there is an interesting story I want to share with you. The Native Americans, they have kind of their own, I would call it, extended definition of sustainability. They not only say we should not harm or impact the future generations, they even say we should not harm or impact the next 3 future generations. So they become even more specific, and whatever they do, maybe you heard, maybe you know, they're very, very close to Mother Earth, and they are very, very careful with their decisions, what to do now and how does it impact the future. So that's kind of the introduction to the story of sustainability. And now I want to share with you this little graph, and this is how it's usually visually presented. So that's now the second element of sustainability. So sustainability is one expression, but it has 3 elements behind. So we have the environment. This is where we live. Yeah, this is what is surrounding us. Then we have the social aspect, which is us people. And then, of course, there is money involved. There is the economical background. And per definition, where those 3 things overlap, this is the famous sustainability or sustainable approach. I personally do not like the left side. I personally prefer the right one, which is called the nested view or the real life. And I will explain you why. Because from what I believe, who was there first? Nature, the earth was there first. And then suddenly we came up on the face of the earth. And at a certain point in time, I don't know, fortunately or maybe unfortunately, we decided to create something which is called economy. So the money got involved, which made things maybe not so easy. And that's why I personally think sustainability starts with the environment. It does not start with economy. It does not start with us. It starts with environment. And I will come back to the topic a little bit later, just for you to understand how I think. A lot of the things you hear, of course, I do my best to be objective, but it's hard for a person to be objective because there is always our mindset behind. So that's the first term that I wanted to clarify with you. And the second one is, not sure if all of you know it, it's what is called a brownfield. So there are 2 different types of sites, and one site is called greenfield, and the other type is called brownfield. A greenfield, per definition, is a site that has never been used before. So it's kind of green, nothing happened there, nothing constructed, no, let's say, no human impact so far. A brownfield site is a site that has been utilized in the past. And we tend, whenever we use some things, we usually make it better, worse, not better. So a brownfield site comes with a negative element. It comes with a pollution. It comes with a building on top of it. It comes with some underground infrastructure that is buried over there. So a good definition is coming from the United States, from the environmental protecting agencies. So what you should remember, a brownfield is always a property. It's a real property. It's something that we want to use, and we want to develop it. We want to redevelop it because it already has been developed once. So it's about a redevelopment and a reuse. And the issue that we face with the brownfield is, the problems that we face there, we find there. So it could be, as I said, hazardous substances, pollutants, or contamination. So this is now the second definition that is important for us when we continue through today's course. So keep those two things in mind. We have the sustainability part, and we have, on the other hand, the brownfield part. So first question, a question that always arises, and you will learn today a lot about the controversy of sustainable site selection. Why? It's in our DNA, I would say, always to ask the question why. Children are very good at that. The older we get, usually we forget to ask the why, and we tend to do what is told. I'm very, very into asking why. Whenever somebody approaches me, you should do this and that, and my first question is why. I want to understand why I'm doing things, and I hope I can answer to you now over the course why this is so important. Why are we doing this? And it should make sense to you. If you say, Martin, that doesn't make sense to me, then either I did a bad job, or you have a different opinion, which is fine too. So everybody can have its own opinion. So please, the next slide is not a typical slide. I avoid words as much as possible, but I still want to share this with you. There is in England an organization called Sustainable Build, and they came up with this interesting definition of why to reclaim and reuse. Don't read it now. I will explain it a little bit better, but I put it just here for you. Let's start with this one. Why is this so important for us, for the world? No secret, the number of people on the face of the earth is growing, and it's constantly growing. The rate of growth slowed down a little bit over the last years, or will slow down a little bit more. That's the forecast. So that's why the curve starting with 2030, 2050 starts to flatten a little bit. But what is more important, and this is now really the key element, more people will live or are going to cities. And the number of people living on the countryside is dramatically going down. And that puts a challenge in front of us that we have to deal. No matter if you're an urban planner, if you're authority, if you're engineers, whatever, we have to think, how can we address that more and more people are moving into cities? So here some figures. In the 1900s, you had around 2 out of 10 people living in an urban area. We already reached almost 6 people living in an urban area, and it will be even more in the future. So this is what we're facing, and this is why, one of the biggest why, we have to think about brownfield redevelopment. I like math. I'm a big fan of figures. So I played a little bit around with figures. to to visualize what's going on here. Very simple information you can grab from the internet. You can do some research. So the surface of the Earth, biological productive land. So I got this figure, the latest figure from 2019. So you see from the whole surface of the Earth, those 510 million square kilometers, around 122 million square kilometers are actually biologically productive. So the world population is already above 8 billion. I did not put here the latest accurate figure. I think 8 billion is sufficient for this calculation. And then there is one figure which maybe I have to explain a little bit. It's called biocapacity. So that's the surface each of us requires to live. That includes what we need in order to survive. So all our, to grow our food, just to live, to where we're housing. This is what we need in order to exist. Every single person requires around 15,800 square meters. And if you compare that to our actual ecological footprint, that is around 27,700 square meters, you see that already right now we're using almost double of the surface that is available to us. And if you look at, turn that into a graph. So this is a very famous figure called the ecological deficit. So here you see the red curve is this ecological footprint. That's the amount of surface we need. And the green curve, the one going down from bottom left to top left to bottom right, is the biocapacity. So that's what is available on Earth. And as you can see here from this graph, around until 1970, there was an ecological reserve. So there was some land still available that we humans did not occupy to live. Starting from 1970, the situation really got worse and worse every year. And you see the ecological deficit is growing. And interestingly, it's not so much that our ecological footprint is continuously growing. We somehow managed and understood that we have to decrease or at least keep stable our ecological footprint. But on the other hand, that's the problematic part. We are still destroying too much of the biocapacity. And this is why the gap is still increasing. So that's kind of the story of why we should do something. And now, how can we do that? And before we go really into the solution, now I gave you a little bit of the why. And now I also want to fill you in a little bit on the legal, technical, and the financial side of the subject. So far, so good. Any questions for this first piece? Something unclear? Just feel free. I have an English channel with the interpreter, so speak up in Ukrainian, and I will hear the question in English, so we can communicate. If there is no question, I give you a few minutes, 1 minute. If nothing is coming up, then I can continue. Or you can also write and tell, okay, there is no question, all clear, with some emojicons or whatever. We will find a way to communicate. Good. Okay, seems everything.
I'm sorry, actually there seems to be a question in the...
Yeah, there is research. I'm not sure if you can read it on the slide. There is an organization called the Global Footprint Network. And this Global Footprint Network is publishing a report regularly and is monitoring what's going on. So this is the latest report from 2022, and yes, they are doing this constantly and monitoring and updating the figures. And you just go on the internet and you put their Global Footprint Network. It will point you to their website. There you can see the report. So there are people and organizations very closely monitoring what's going on. I hope that answers your question. Thank you for the other comment, clear and interesting. Very much appreciated the positive feedback and some little interaction. Okay, then we go a little bit further. Now it gets, I don't want to say too technical, but I think all of us, maybe not everybody has the same background knowledge. So let's go further with legal, technical, financial background. Maybe this is familiar to you. This is the UN Sustainability Development Goals. There are 17 goals, and even in those 17 goals, our subject is included. The closest overlap we find in the goal number 15, which is called Life on Land. It's this greenish one. This one here in the middle. So this is where we are. This is the sustainability development goal number 15. And it says, protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and halt biodiversity loss. That's exactly what we talked about on the first slides. So we have to wisely choose and use the land for our projects. Of course, more people need more houses. We cannot say, we don't build houses anymore. That's not working. And we have to be realistic. But we can choose where and how we build houses. So more specifically in this goal number 15, you have a goal with the number 15.3, which says by 2030, that's very soon, combat desertification, restore degraded land and soil, including land affected by desertification, drought and floods, and strive to achieve a land degradation neutral world. So that's a very, very ambitious target, easy readable, but actually what they are saying is that by 2030, this decrease in biocapacity should stop. Now you have to think about the curve that I showed you. So what they want to achieve is that starting with 2030, so in 7 years from now, the green line on the slide before becomes horizontal. That's what they want to achieve, and that's huge. So let's see how we can make it together. Maybe we can contribute a little bit on our end. So that's the part on the worldwide level, how our things are included in the big picture, our topic, our today's topic. So the second thing I want to share with you is, I'm not sure if you had that course already or if it still will come, is about the green building rating certificates or rating tools. And I found here a little comparison between the two that are the most common used worldwide. So One is LEED, which is coming from the United States, and the other one is called BREEAM, that's coming from England, from Great Britain. So they kind of do a similar thing. They're evaluating buildings or projects. We have to say projects, not just buildings, projects, green building projects, but they have a different certificate. So BREEAM calls them pass, good, very good, excellent, outstanding. And in LEED, it's more classical. It's called silver, gold, and platinum. As you can see by the number of certificates given, there are many more certificates given under BREEAM than in LEED. I describe the differences let me describe it with my own words. They have certain areas or points they are giving, and they have many that are common, overlapping, but some of them are specific. So I would say around, I don't know, 60% are kind of overlapping, and the remaining 40% are very different in both certificates, both systems. But the main difference is that LEED is what I call more an architect-friendly creative system. So there is not very rigid, you have to do this and use this type of material and this type of window and this type of roof cover. It's more a generic thing, a generic approach, a creative approach to achieving certain targets. On BREEAM, it's very different. It's much more strict. It's more rigid. It tells you exactly, if you do this, then this happens. So on the LEED side, the certification process is more like a negotiation, a discussion between the assessor and the project owner, while in BREEAM, it's more, there is a person coming, checking what you did, and like a teacher giving you marks. So some people feel more comfortable with the LEED system. Some people feel more comfortable with the BREEAM system. It doesn't matter which one you use. It's important that you use it, and it gives you a little feedback, an outside feedback, how you are doing with your project. And again, somebody could say, why am I doing this? It just costs extra money. True, it costs a little extra money, but it also gives you a benefit because it adds a reputational element to your project. And funny side story, LEED started in the US or became famous in the US when some so-called celebrities like actors, I don't know, one of the most famous ambassadors of green building are, for example, Leonardo DiCaprio or Brad Pitt. So they were very communicative, said that I'm living in a green building, in a certified green building. And then everybody said, yeah, if DiCaprio or Pitt is doing it, then I have to live there as well. And suddenly the demand for certified buildings went up. And so there is also kind of a financial reward, maybe not guaranteed, to certifying a building. But I hope we are doing this not just for the money, we're doing it because we believe in a better future. We want to do things better, and we want to do it sustainable and hand over a better world to the next generation. But I just wanted to share with you, the systems are there and what they can do to your system. So now a little bit into the system, that you understand how this is related to our subject. So I shared with you a few of the rating aspects from the LEED system, so that you see how they are connected to the subject and to your projects. And one aspect so the newest version of the LEED certification is the version 4.1. They're currently in the process of issuing version 5, but it's not yet there. So we go with 4.1. And the BD plus C is building development and construction. So it's for new projects. They have a similar system for existing constructions. They have a similar system for hospitals, for schools. So they distinguish between different types of projects. But for us, this one is the one we have to go with. And as you can see here, you get points for neighborhood development, for the location, for sensitive land protection, for surrounding density, access to quality transit, which means you can use the bus or you can use the train or the tram, whatever, subway. So this is what we're talking about. And now maybe you already see where am I going. If we're talking about developing a green field, think about a city. Where do you usually find green fields in a city? They're outside. So whenever you do green field development, what happens to the footprint of the city? The city becomes bigger and bigger and bigger. So the biocapacity goes down and down and down. I hope now it starts to make sense and to fall all into place. So the idea is, now we are to Brownfield, we are looking for areas inside the city that are currently not used anymore for whatever reasons. And we have to make sure that we redevelop those areas and use those for our new projects instead of going to the green fields outside of the city. So another one is sustainable sites. So you get a lot of points for picking a sustainable site. There is about the site assessment. We will come back to that. Protecting and restoring habitats. Of course, if I don't use a green field, I'm protecting a habitat. So I get points for my projects. I get a higher ranking. I get maybe a silver, a gold, a platinum, or whatever system you want to use. Heat island, we will come to that. Light pollution, we will also come to that a little bit later. This one is more related to site management. It tells you how shall I do the design of my project in order to receive those points. It's 10 points. It's a lot. And the last one I put here for you is materials and resources. Here we are talking about waste. How do we deal with waste? How do we deal with materials that we use in our projects? And we will have a little discussion, and I brought you some practical examples because I think pictures and practical examples explain better than a lot of words. But what is important for you when you think about your projects, you have to think about the life cycle of the project, the life cycle of the building. In the past, it was very common, I'm building a building. I'm just building it, yeah. So my focus is on shall it look nice, and this is how I want to use it now. It should be an office building, yeah, that's it. But that's not how it works, because when you look at urban development, even areas or even whole cities change. They're like now I'm lacking the word. A living creature, so they're not all the same, not the same all the time. And an area in a city that might have been office in the past can change into housing. So if you made a building design for office and you didn't think about that you might want to change it into housing later on, you have to do a lot of reworking the whole structure. But if you as an architect, if you as a structural engineer, or even you as an authority request the project owner to include in the whole design even the aspect of a potential change of use, may it be from housing to office or from office to housing, then you design the building in a different way. You put the supporting structure maybe in a different way. You make the walls easier movable. You avoid a lot of generation of waste later on. So this is what is called building life cycle management. And even at the beginning of the building, you already think about, what will I do at the end of the life of the building when I demolish it? So the materials I choose at the beginning already include in my thinking process the potential solution for demolition at the end. So you really have to see the big picture. This is what this is all about.
Ține și despre, uite, vezi, fac partea asta de deșeuri, storage.
So, this is a very recent development, and I thought that's maybe interesting for those of you who are into financing projects. Finally, I'm so happy that it happened. On the EU level, they issued a legislation that promotes a sustainable green approach. Not so much from the technical side, but from the financial side. And in June 2020, a legislation was issued on the EU level, which is called EU taxonomy. And what is it all about? It's about a kind of certificate. It's really a certificate for green investments, for green projects. And in order to qualify for such a certification, for such a certificate, they introduced 6 targets, 6 objectives. So you can read them. Here one is called climate change mitigation. The second one is climate change adaptation. The third one is sustainable use and protection of water and marine resources. Transition to a circular economy, pollution prevention and control, and 6, protection and restoration of biodiversity in ecosystems. And here again, this is repeating and repeating and repeating. You find our subject here again. It's about pollution prevention, about remediating brownfields, protection and restoration of biodiversity in ecosystems. Finally, in this legislation, the EU said, if you want to give a credit to a project, make sure this project meets those targets. Otherwise, it's not okay. So when now, and this already changed a lot the financing world within those 3 years, now people are really asking, before investing in such projects, do you have EU taxonomy approval? Are you according to EU taxonomy? So this is a very, very important subject from the money side. Money, unfortunately, our 3 sustainability elements, environment, people, money. Let's be honest to ourselves, money is still running the world. But finally, with this piece of legislation, we brought also the money side into the sustainable thinking approach. So, the issue here is, in order to qualify, you have to contribute to at least one of those 6 objectives. So now this is you have the 6 objectives. You have to positively contribute, make it better, one of the 6. And the second criteria is you're not allowed to harm the other 5. So it's not that you focus on one and you make the other 5 worse. No, you pick one of the 6, you make it better, but you keep all the other 5 on a similar level. So if you do this, if you meet those 2 criteria, then you qualify, then you meet the requirements of the EU taxonomy. So now I want to give you a little bit more insight about those brownfield sites. At that point, I don't want to spoiler now the story later on. That's why at this point in time, I'm telling you, okay, if we have a polluted site, we might need extra money to clean it up. So when you compare a greenfield and a brownfield, there is a cost element on the greenfield side that you don't find on the brownfield side that you don't find on the greenfield side, which is the contamination or an existing building. And everybody will say at the first glance, yeah, but those are extra costs. So therefore, the brownfield development is more expensive than the greenfield development. Let's keep it at that point at the moment. I will touch that subject again a little bit later on. So now when we look at this element of brownfield extra costs, we have to analyze the properties. And there was a very good study in Croatia done by Tokic and Sumpor, and they came up with this ABC model, which illustrates very nicely where we are going. So what you see here, let me use this fancy tool here. So on the horizontal, you have here what is called reclamation costs. So it's the money, this extra money we have to invest to make the to remove the impact of the brownfield. And on the other side, we have here on the y-axis, we have the land value after the reclamation. So what it means is, if we have to invest little money in order to increase the land value, then we have what they call is an A site, a self-developing site. If we have to invest a little bit more money and the land value afterwards is not that high compared to the initial value, then we're somewhere in the middle, which is called potential development sites or B sites. And if the situation is so worse that we have to, so bad that we have to invest a lot of money in the cleanup and the land value only goes up a little bit, this is what they call a reserve site or a C site. So what does that mean? That means everybody is interested to develop a project on A sites because those are quick wins, easy wins. Yeah, you invest a little bit, boom, afterwards your site is worth double, triple, whatever. On the B sites, it usually requires some extra money. So the project owner, the investor, is not so confident anymore that it makes sense to him to work on that site, and then he needs some support from the authorities. So this is where these famous public-private partnerships come into place. And the reserve sites are sites that are definitely at the first glance not worth it to develop because you invest so much money. And those sites usually only are used if there is a strategic advantage. So those are projects that must be driven by the city, by the county, or even by the state in order to get them resolved, to get them developed. So this is a nice model. Keep that in mind. We will get back to that also a little bit later. Okay. Working. It's this one here. Here I put together a few EU funding instruments that are soil related, so they are related to our subject. You can read them by yourselves later, just for you to know. Usually the problem is not lack of money. There is more money than we all think. There is so much money out there that is available. The question is, can we convince people to spend this money on our project? And that's actually the critical or the tricky part. And the money you find here in the list or here in those funding instruments, we can easier access if we use the sustainable approach, because then we are contributing to the goals of those funding instruments and we qualify for a funding. So here again, the connection between sustainability and money. If you achieve a certain target, then for sure there are people out there who will give you the money. You just have to do it the right way. Good. Now the two final slides on these chapters. Maybe at this point of the course, you're asking yourself, yeah, okay, that sounds nice so far. Why are not more people doing it? And the next two slides are answering this question. Yeah, it's a great concept. It works very well in reality. It's just that there are several problems, issues you have to deal with. And if you're not expert enough, if you do not know all the tricks, not trick in a negative way, in a positive way now, you have an issue in communicating it to the people who are giving you the money. So that's why we need to understand the issues that we can properly address and communicate them to the authorities, to the investors, so that we get our projects going. Unfortunately, we still have no international and EU brownfield policy or legislation. It does not exist, not on an EU level, not on an international level. It only exists country-wise, very, very different, very, very specific. There is no big picture. The only big picture that we're having is the UN sustainability goals, the development goals, EU taxonomy on the EU level, and some isolated legislation in the EU that addresses the problem. But the big picture is still not there. We have a lack of tax incentives. And here, again, a little side story, not so relevant to us because we're living in Europe. The brownfield subject started in the United States around 1993. So quite some time ago, but they were actually the first ones who thought more about that topic, and they came up with instruments, also with financial instruments, to make brownfield development more attractive to investors, to project developers. And what they did is they introduced some tax incentives. You know, owning land comes with property tax. So what they said, hey, if somebody is investing in a cleanup of a polluted site, you don't have to pay property tax because you anyway spend money in the cleanup. So they came up with a tax exemption for land that was cleaned up. Or if you develop a polluted land and you then build a factory on it, that's your business. Yeah, you want to make money with your business. You make profit. They give you, for example, an exception from profit tax for a period of time in order to compensate the investment you had at the beginning when cleaning up the site. And those are just two examples. So it's about coming up with ideas how we can make people invest in brownfield sites versus greenfield sites. And the authorities, the government, the state are part of that decision process. We need their support. We need to explain to them why we need the tax exemption and why it benefits all of us. We still have the problem with, on the legal side, with the policies related to remediation and investigation. When I came to Romania 20 years ago, they had almost no legislation on cleanup of polluted land, nothing. So I was part of the mindset building in the country in order to tell them, hey, this is what you could do, that is what you could do. So this is what you maybe can do in the Ukraine. Train people, train the authorities, train developers. Hey, we need to do something with regards to legislation towards remediation and investigation. Once you have legal security, it's easier to implement such projects. That is also linked to the liability. So if I take a piece of land that was polluted, I become liable for it if I don't know who was the polluter. We come to that later. So it comes with liability, and people ask questions. Okay, what is my exposure in future? And the last one, to me, sometimes is the most important one. The subject is very, very new to many experts, and even to experts. There are not many people out there who understand what we are talking about today. That's a pretty new subject. And put yourself in the shoes, for example, of an authority. You are responsible as an authority to approve a project, and you should assume some responsibility by issuing a permit for a project without actually fully understanding the implication, the topics, the subject. So we have to train experts, we have to train the authorities in order to support us in implementing those projects. The next one is very clear, and this is then the link later on to the practical examples. We face challenges on those brownfield sites. We don't have maybe information on the site because it's an old site. It has been, I don't know, was used in the 1800s, in the 1900s. We have no information. That's bad. We need information. So having no information is a problem for us. We need to understand the contamination. We need to understand what is on site, what is buried in the ground. So there is a lot of technical related questions that we have to answer before we can move ahead. Good. That was another set of information I wanted to give to you. So first, more generic, now already more detail. Again, questions. Understanding problems. Shall I become a little bit more specific on some topics, or still you're okay with how we're moving?
Perhaps I would have a question. Maybe in the meantime, if anyone else have raised your hands. I'm recently I'm more and more seeing projects where on the building sites there is a will to protect the trees and the tree root systems as much as possible. So even the buildings are using the systems of pillars instead of just just making a big hole in the ground. So maybe from the legal perspective or the perspective of where the legislation is moving on, do you think that is this more of a trend of kind of more kind of hippie style of tree huggers, or do you think that this is going to soon to become a standard, at least in the EU in the upcoming years?
It's not a tree hugger thing. It sounds funny at the first glance, but there are many aspects behind. I give you a few of them, and later on you will see the specific slide that addresses that also that subject. With trees, you have several elements. The tree takes water out of the soil. So you have the element of water management on site. In many projects, or no, let me start differently. In few projects, I have seen a clear strategy on how to manage water, rainwater on site. Most people don't even consider that aspect because they say, I don't care, it goes down the drain, and that's it. No. Yeah, of course, yeah, you can send it down the drain, but first of all, you pay for water you send down the drain. At least that's already implemented in most countries, and where it is not implemented, it will be implemented, because otherwise you cannot maintain the systems. Second, if I can use the water on site for irrigation, I save a lot of water in water consumption. Third, the tree reduces the local climate of my site. And this is where we address what is called the heat island effect. But I don't want to explain the heat island effect now, because we will come to that a little bit later. So the answer is yes, it absolutely makes sense to protect all the trees that are on site. And this is what I call design around obstacles. Take what the site is giving you. If the site is giving you trees, use the trees in your design. Find a design that incorporates the trees. Okay, I hope that answers this question. There is a written question, models on how different countries have implemented the taxonomy. Not yet, because it's a little bit too young. There are, unfortunately, it's all about money. As soon as the taxonomy was published, 100 companies popped up who developed an online modeling system where you can introduce data from your projects in order to see if your projects, if your buildings are taxonomy compliant or not. So there are already many, many providers out there who offer such online systems for, let's call it, taxonomy management. Because every building owner, every portfolio owner from now on has to monitor all their buildings if they are taxonomy compliant or not, and how they will make them taxonomy compliant over the years. So partially, yes, there is already systems where you can find the data, but I'm not sure if those data have been put together in studies and published. So we will find the data already. I can even, if you want, put you in touch with somebody who is running such a system. I met him, really cool. They started investing, they started a business. They took it very far already. They're still evolving, growing, changing. If you're interested, I can point you to certain companies who are doing that, and maybe you can contact them and figure out if they're willing to share some information.
My question is not regarding the way we can check or we can monetize the decrease of money. My question is because the different countries have so much different legislation, and we as European Union at this level, we do not know what one country is doing that could become a good model for another country. Romania is underdeveloping. It's looking a lot of what is going on the West, and there are some forces in the country that tries to promote such models, but they are not not visible unless you are present in that particular market. For example, I'm working at one company that's producing aluminum. And for us, for example, from time to time, we present to our clients a report stating, yes, in this country, we produce this amount of materials. And for our clients, we have decreased this amount of money, because unless we talk about the money is such a powerful engine, and it will move things forward. So this is my question. If there is any presentation or integrated overview, what different countries have done in the European level?
No. Luckily here, the EU takes, usually when a legislation is issued on the EU level, I would call it more generic, and then you're supposed to transpose it into national legislation. So take what the EU put out there, and not sure how much you involve yourself in how decision processes are made in the EU. Because of so many different member states and due to so many different agendas, it's very, very difficult to agree on the EU level on a specific legislation. That's, for example, exactly that's the reason why we still don't have the soil directive issued on the EU level, because there are states, still states, who are objecting against the EU soil directive. They don't want it because they think it is a disadvantage for them and it will limit their financial growth. So again, money is above anything else. The EU taxonomy is, I would say, a little bit different. It is pretty specific already on the EU level, and there is not really you have to transpose it into something national. You just have to use it, but the level of detail on the EU level is already so good that you can just take it and use it. What you're saying is an issue. Because all those models that I mentioned before, those companies who develop platforms, online platforms, systems that shall be used in order to monitor your efforts are black boxes. You do not know what they programmed behind and how they programmed them, and you're using them, and actually you don't have a guarantee. Are they taxonomy compliant or are they not taxonomy compliant? So my recommendation to you is, whenever you're about to use such a software, you have to challenge the company who is selling that product, and they have to explain to you very, very specifically how they incorporated all those requirements from the EU taxonomy into their product. So not just accept it, but be critical. And I agree with you that the subject of greenwashing, or the subject of just giving a statement is not properly analyzed in many cases. So Vienna Airport, good example. They have those huge mega boards making advertisement. We are carbon dioxide neutral airport. I have my doubts, they are, but it's easy to tell, yes, I am. Who is challenging it? Nobody. So you have to be very careful with all those certificates and statements. Just be critical and ask, why do you think you are? So asking why is always a good starting point to challenge people, and you will realize they become nervous and usually don't have answers. I hope that answered a little bit your question. Good. As we talk money, I want to give you that subject as well, because it's not easy to answer. It's really, really complicated to answer. Let's start with the liability side. Here we have a new legislation. It's called the Environmental Liability Directive. And what it says, it has the so-called polluter pays principle. So whoever caused the pollution has to pay for it. So far, so simple. But, and the tricky part is, most of what is called historical pollution, old pollution that happened in the past, the people who caused it are not there anymore, are sometimes not even known, and definitely cannot pay for it. So polluter pays principle is nice, but it only works as long as the person who caused the problem is still there and financially capable to pay for it. And this is where it becomes tricky. If the polluter does not pay for it, the landowner has to pay for it, even if he didn't cause it. So here, the critical element of brownfield development is, and my recommendation to any of you who is into buying land, developing sites, never ever purchase a piece of land that you have not investigated. If you purchase a contaminated land and you find out later on it's contaminated, the authorities will come to you and maybe ask you, or not maybe, will ask you to do something about it. And although investors usually say, but that costs money, the investigation, it's so expensive. It's not expensive. Yes, it costs money, but compared to what you pay for cleaning up, the investigation costs literally nothing. It's not even a digit behind the comma. So the cost for remediation can be so high that the investigation is really nothing. You can pay it from the petty cash. So it's important to understand, what am I dealing with? And for the authorities, if there are some authority people today present, the most important thing for you guys is that you have a database on the country level of contaminated sites. So make an effort and force, sorry for using the word, but force the landowners to at least provide a certain amount of information that allows you to build a database for polluted sites. Because you need this data for a strategic development plan of the country in order to decide on legislation, to decide on prioritization. You need this information in order to take decisions for the future. So this environmental liability goes in many different directions. Remediation costs. Very often I get asked the question, yeah, how much does it cost? And my answer is always, sorry, I can't tell you, because every project is so different. It depends on, is it just the soil? Is it also the groundwater? How big is it? Which type of contaminant is it? Which strategy do you want to use? So the variables in this equation are simply so many and so different that it is difficult or almost impossible to give a figure, and it would not be professional. What I can tell you is, if you do it wrong, it can be very expensive and it can take a long time. So the most important element is investigation, investigation, investigation. Only after you understand it, you can really properly decide what you do. But this we do in the next session. And the second important information for you is, remediation is not something that only is relevant for the land that you are using for your project. It has an impact on the neighboring plots as well. In most of the cases that I worked in my career, if there is contamination on one piece of land, there is usually also contamination on the neighboring plots. And you are responsible also for this piece. Because if this is your land and the contamination came from your land, it's not the neighbor's problem, it's your problem. So you also have to understand, where did it start and where did it go? Maybe it started there and came to you. That's the best thing that can happen to you, because then your neighbor is the responsible one. So we need to understand, where did it start, where did it go, how big it is, how deep it is. Then we can decide how we treat it and how we move forward. We already had that piece. As an authority, as a government, you have to really think, how can you make it attractive for people to do brownfield development? You have to give them something, and then you get something back. What do you get back? If you have let's assume there is a contaminated site in the middle of the city, an old factory, already closed, bankrupt. Nobody wants to use it because there is so many problems. I don't want to touch that piece of land. For you as a city, this is an unutilized land. It might have a health impact on the city. It might have a health impact on the people living around the area. You're not receiving taxes on that piece of land because it's not used. So there is a lot of incentive for the city, for the authorities to promote the treatment, the reuse of the land. If this land is used, if the land is brought back to life, you have again profit, tax on profit. You have profit taxes on salaries if people are working there. You increase the land value of this piece of land and of the surrounding land. Also, the land value goes up. You bring back business to the location. So there is a lot of benefits that at the first glance are maybe not visible. And it goes even bigger. And maybe you think I'm exaggerating, but actually I'm not. Look at it from the health system. A greenfield development, a new factory out of the city, outside of the city, people have to go there by car usually. So they're sitting in the car, traffic, pollution, they're just sitting, driving, bad for everybody. If you put the same factory in the middle of the city, maybe most of the people working there can just walk to work, take the bicycle, save extra hours for their family or for doing sport. So overall, people are healthier. And it has a positive impact even on the social security system because the state later on has to spend less money on people who become ill because they're sitting too much or not working out too much. You see, you can take that bigger and bigger and bigger. And in order to make it interesting as a project, you really have to think big outside the box and look at different aspects and not just at your single project. There is many more stakeholders. There is many more advantages. You just need to see them. Last but not least, the time issue. Remediation can take long, and it requires proper experts in order to take the right decision for you. I want to skip that here a little bit faster because we will come to that a little bit later again. And what can, for example, the authorities do to speed up the process? There is something that has been introduced in the United States, which is called fast-track permitting. No offense, just please don't take it personally or against the Ukraine or any other Eastern European country. I worked a lot in that region, and what I learned is the processes are pretty time-consuming and bureaucratic, and it takes a long time until you get a permit for a project. And many of those steps are, I wouldn't say unnecessary, but repeating and take longer than needed. So if you as an authority want to help a project owner, help him. If he's working on a brownfield, said, okay, if you do brownfield, I'm helping you. I'm giving you the most efficient permitting process possible. I will help you as much as possible. I will prioritize even your project in order to implement it faster and improve the situation faster. So there is ways the authorities can help. And there is also an interesting project where I participated in. It was between Germany and Romania. So the Romanian authorities did not have enough experience on remediation. So they invited German government or authority representatives to come to Romania and teach them and train them how they are doing things back home. And that really helped to them to understand, okay, now it makes sense, I can do that. So that was a cool project. I also give you the downside of this project. as soon as the government changed, most of those trained people were replaced by other people, and then we started from zero. So if you use that approach in the Ukraine, just also make sure that if there is a governmental change, they're not changing all the people in the authorities that have gained experience over the years. So this is important to keep a level of knowledge at the authority level so that you can build on it. Otherwise, you're starting all over again. Good. We finished, I would say, the theoretical part. We're perfectly in time. It was kind of half of the course. What comes next are chapters practical, pictures, explanations, examples, how to do what you just heard. So far, I want to make sure that you understood the topics we covered so far, because all of this will now show up in the second part, but in a more practical way. So please let me know if you need some additional, if I shall fill certain gaps. I don't know. Do you need a break? Do we continue? Eva, what have you done in the other courses? Should we make a 5? I can talk. Yeah, for me it's not a problem. But maybe, I don't know, bathroom break, something to drink, a bite. I don't know how you want to do it.
Did practice a 5-minute break before. So maybe, I don't know, are there any hands up or any suggestions from the participants? Any reactions? Maybe, yeah. I mean, if we are on time, yeah, maybe 5 minutes. Just not to break the focus would be perfectly enough. Just to grab a coffee.
Then let's do. Okay, wait. On my clock, it's now Kiev time. It's 11:27. Correct?
Yes.
So let's start 5 minutes past. So at 11:35, is this okay?
Yeah, that's absolutely fine with me. Yeah. And
good. Then let's take a 5-minute breaks. I grab a glass of water, and then we continue.
Very well. Yeah.
Perfect. See you in 5 minutes, guys. So I am back, guys. When you're ready, I'm ready. We can move forward. Wow, I didn't realize that the numbers went up from 33 to now 46 participants. Wow.
Yeah, the pressure is on, yeah. But it's great, yeah, to have an
Okay,
increase in number.
guys, let's get moving. Let's talk practice. As the title indicated of the webinar, there is an element of site management and the site and an element of site selection. I'm starting with the site management part. When we talk here about sustainable site management, it has kind of two aspects included. One is during the execution of the projects or during the implementation of the project, but also once the project has been implemented. So this is kind of covering both phases of the project, before operations and while operational. Okay. Good. Yeah, from now on, we will work more with pictures, and then I will give you a little bit of the story around the picture. I'm not sure if you remember from one of the slides before, from the LEED certificate, there is an element which is called erosion or pollution prevention control plan. So this is how it is called correctly, and it is mandatory. So no matter how good your project is otherwise, if you don't have a pollution prevention control plan, you do not qualify for a LEED certification at all. And here we're talking about that during construction, you're not polluting the surroundings. It could be soil, it could be dust, it could be water, whatsoever. And what you see here is just an example of erosion control, simple solutions that help you to avoid, in this case, erosion and runoff, stormwater runoff to neighboring properties. So before you do your project, you have to analyze, okay, what are the potential impacts of my project, in which phase, and how do I mitigate them? And a little advice from many years of practice: do a baseline assessment. So check how does the situation look like before, do some measurements, do some monitoring, and continue then the monitoring throughout the project until the end, that you have really a proof that it was not you who caused certain problems. A very classical example is that then people come, yeah, because of the vibration, I have here a crack in my house, or some glasses fell off the shelf and you have to pay for it. No, it was not me. It was there before, and learn how to hold the glass. So it's just that you have to keep that aspect in mind. Baseline assessment, monitoring, and then you usually don't have problems during execution. So the next example, I know in these pictures it's hard to see, but I want to share it with you because it's a pretty cool and simple applied solution. What you see here in green is a geotextile. Maybe some of you have experience with geotextiles. Usually they're made out of polypropylene. In this specific case, it got a green color. Usually it's gray or grayish. And the reason why it is green is it should somehow indicate vegetation. You can see, hopefully you can see that it has holes in the geotextile. And what you do is before you put the geotextile, you put the grass seeds on the slope. And the geotextile does two things or three things. First of all, it looks much nicer than the brownish soil. So it has a visual aspect. Second, it protects erosion in general. And third, it protects the seeds and gives the vegetation, the grass, the time to grow. And then it just simply grows through the holes and it stabilizes the slope. And because this is a polypropylene geotextile, it is not very resistant against sunlight. So the UV rays in the sunlight will degrade the geotextile over time. So ultimately it will disappear by itself. It doesn't matter even if it stays a little bit longer because it will be covered completely with grass. It's a nice thing you can use in order to for erosion protection, pollution prevention, and you will have much faster green slopes. Now we come back to an element that was also in the certifications, which is stormwater management. And now we are back to the trees that we want to protect. So when you do the design, when you think about site management, the basic rule for a sustainable, for a green project is handle the water on site. Find a solution to manage the water you generate on site. You can reuse it, you can temporarily store it, you can make sure that it infiltrates directly. And this is what you see here. It is very popular nowadays to put asphalt or to put concrete for a parking place because it's low maintenance. I have to agree. It's less maintenance work than this one here. But all the water that falls on a paved parking place, you have to manage. If you have here water falling on the area, it will just simply infiltrate. And it has another aspect which links us to a topic that will come up in a few slides. It reduces the temperature on site. So this is the best solution because you don't have much material that reflects the sun. Concrete would be the second best because it's brighter, there is more reflection, but still heats up the concrete. And the worst solution is tarmac, asphalt, because it's dark, it's black, it heats up, it absorbs most of the sun energy and reflects it later on. So it increases the heat in the area. And one of the elements of sustainable projects, of a sustainable site management, is managing the heat island effect. Yep, yeah, that's true. We have, of course, also, especially with asphalt, the part with the gases, with the volatile compounds in the material above a certain temperature. Thank you for this input, Anka. So, how can I manage a side story to this picture? One of the earlier courses I did, we had a participant from the environmental authorities in Romania. And this person said, I do not agree to that solution because it might lead to a pollution of the soil. And you have to understand that at that time, there was still a lot of cars in Romania that have not been replaced. And the issue of leaking cars on parking lots was definitely more serious than it is nowadays. Nevertheless, I said, I fully understand your point, but I also have a solution for you. So theoretically, what you can add, if this is an issue for you, you can put under this structure, you can put even a geomembrane as a protecting layer below. So you still have a a soil layer of, I don't know, let's say 0.5 meter to 1 meter that can absorb water. So you have a storage area for water, but you collect the water on the geomembrane, and you, with a little slope, you can guide it in a direction where you collect it in a oil separator, and then you can reuse the water. So I like to say there is a technical solution for almost every problem. So although maybe at the first glance this solution does not look attractive to you, you can make it attractive with a simple additional measure. The next one I like a lot. I'm not sure if you're familiar with this. This is what is called a soak-away chamber. Ultimately, it is prefabricated pipes. They have this profile that you can that you see on the picture, which makes them a little bit more stable. So they're really strong due to this profile. And you can either keep them empty inside, or you just fill it up with gravel. You can cover them with gravel. This is a huge underground storage basin that is not very expensive and easy to be constructed. You don't have to build a concrete basin. You can simply put some gravel, the pipes, and what you see here in addition is some geotextile. This is a black geotextile in this specific case, which protects the infiltration of fine material in the gravel. So you create a huge volume, storage volume for water that you can use for irrigation on site, or just simply store it over there. So there is no need to send all the rainwater into the drainage system and then maybe pay for the treatment of the water. You can just simply store it on site for later reuse or until it is evaporated. So there are many different options how you can manage water on site. But water management is a big topic, and it's very simple to be solved. So now we come to the waste part. And some years ago, it still was called the waste management pyramid. That's why I put the pyramid on the left side. But actually now it's called waste management hierarchy. And on the right side, you see the way it should look, it should be done. It's about how we manage materials. And I'm really using here the word materials because we should avoid that it becomes waste. What does that mean? When we design projects, and now we're talking really, this is a very specific for brownfields, and you have a situation over there where you find some constructions, old constructions, some paved areas, some foundations. You have to think sustainable, and you have to decide on the strategy how to manage these existing structures without generating too much waste or not generating more waste than necessary. So the first solution is prevention. As long as you prevent, you don't even have waste. The next one is you prepare it for reuse. You can reuse it on site, which is ideal, or you can also prepare it for off-site reuse. The next best is recycling. The next best is recovery, and the worst solution is disposal, which means sending it to a landfill. And please discuss this with somebody experienced, because you will be surprised how much you can prevent and how much you can reuse on site before you go down into the orange, red, or gray area. But be patient for a second. Once I show you the practical examples, this will make even more sense to you. Another element that you saw in the certifications from LEED and BREEAM is alternative transportation. And this is, again, why brownfield projects in the urban area are so interesting to us. So usually inside the city, you have a developed public transport system. So there is buses, there is maybe trams, there is maybe subway. You can use the bicycle easier if the factory where you're working is outside the city and you have to go on the highway, maybe not a good idea to take the bicycle. Inside the city, it's a lot easier to use electrical cars. You can provide charging stations. So those are all elements, although they don't have anything to do with the building. And that's why I'm saying you need to see always the big picture. It has to do with your project. It has to do with the community. It has to do with the city. And a sustainable project is not an isolated construction of a building. It's a project that involves all stakeholders, and we have to go bigger. Another side story for those of you who maybe have been to the Netherlands, you know, they're famous for using bicycles. I had to do for a while over there, and I saw things that I've never seen anywhere else in the world. They have underground parking for bicycles. So when they're designing buildings, they don't put underground parking for cars. They're putting underground parking for bicycles, and you have thousands of bicycles hanging from the ceiling instead of having cars parked. And people go there no matter which weather. They put on a coverall and even take the bike when it's raining. Then they're parking the bike over there. Of course, what you need to include in your design as an architect is some facilities where you can change, maybe some lockers where you can store the wet equipment. Some companies even provide showers. I worked when I was started my career after university. I worked at a company where the general manager of the company was a big fan of racing with bikes. So he was really a professional biker. And when he came to work, he did not come with a suit at all. So he really used it as a workout. So I think he drove some 1.5 hours to work by bicycle. He was sweating. He was completely sweating when he arrived. But because they had some shower facilities, then he took a shower at work, put on his suit, did his work, and at the evening he drove home with the bicycle again, and he had twice a day a workout, and he felt wonderful. So there are other ways of doing it. There are interesting solutions. You just have to think about all the aspects that are related to it. Just letting people come by bike and not giving them opportunities to change or where to store their things is also not a good idea. But yeah, just incorporate it in your design. What you can see here at the background, this is from a project you will see a little bit later. There is a lake, and this lake is beside the factory. So this lake has several functions. The lake is for storing rainwater. The lake is for reducing the temperature. The lake is for irrigation of the plants. And around the lake, they also put up some benches and recreational areas where the people can hang out during lunch breaks and then eat or chat or smoke. It was a benefit for everybody. So sorry, I missed that. So that's why I went back. So here we are, heat island effect. Maybe some of you already heard about this specific phenomenon. What you see here is at the bottom is different areas from the central district with high buildings, with metal, concrete, glass facades. Then you have maybe the commercial area. There are already some trees. We're back to the trees and building. suburban areas, more houses or more trees, parks. So this is kind of, and then you have on top of that, you have here the temperature and the temperature profile over those areas. So what you see is different temperatures depending on where you are. In the central business district area, there are the highest temperatures, and in the rural or park areas, the temperatures go down. And those peaks are the so-called urban heat islands. And our job as project developers, architects, designers, our job is to reduce the heat island effect. We have to take measures in our design, in our sustainable design, that helps us reducing those phenomenons. And how can we do that? We already had some cases. Plant trees, put water surfaces, avoid asphalt, use concrete over asphalt, put green roofs, put green facades. So all measures that reduce the temperature are welcome to fight the heat island effect. Another element in certification in site management is light pollution. And whenever you can do this, do it, because it's makes people feel good. Go on top of a mountain or in a very remote area, lay on the ground and look at the skies. And really enjoy that you can see the stars and you can see the sky. Because you can't do that in a city, because there is too much light pollution. You don't see the skies anymore. You don't see it. There's no stars visible. And this is what we have to do again in order to promote sustainable development, to promote sustainable site management, that we eliminate light pollution. So that's why there is light design. I'm not an expert in light design, but this little picture here indicates what is the idea. So the idea is light should be only there where I need it. I don't need to light up the rest around me. I need just to point the light to where I really need it. And more and more companies implemented, especially once the energy prices increased, started to completely turn off lights in the buildings and even turn off their advertisements. So far, nobody cared, and then everybody said, marketing, nice illumination of the building. So what? This costs so much money using the electricity, and it has such a negative impact on the surrounding people. You can't sleep anymore. So if you're living, best example is, again, negative example in this case, America, New York, Big Apple, you know, this famous place over there. It's never night over there. During night it is day, and during day anyway it's day. So there is always so much light. People living there, they can't sleep because it's permanent light, and that generates so much stress to our body that it always thinks it's day, and it never our brain never shuts down, and that results in health issues. So helping or avoiding light pollution again has a positive impact on the health, and has a positive impact later on the social security system, less money to be spent on healing people that have sleeping disorders. So yeah, this was kind of a little wrap up around sustainable site management, more towards operations. And now we go into some practical projects. And here we have solutions. Those are real projects that have been implemented. Those projects are all from the United States. Why? Because I had a partner, a company that partnered with us. The company was called Epstein. It's an architectural company from the United States. They were active in Romania, and they helped us and the Romanian Green Building Council to develop the course. And when we developed the course, they contributed with some cool information and materials, and I kept them because it is hard to find so detailed information on European projects. So that's why, and it shows exactly what we are discussing about. That's why we have American examples. So let's start with the first one. The project name is not so important. Where are we in the United States? We are in the Chicago area, and the site is around 5.5 hectares. And later on, they created a lot of jobs over there. They put a new facility, a commercial laundry later on. And but what is interesting to us is the right side, the right column. So historically, this site was used as an amphitheater, kind of an exhibition hall. That's, I think, the easier term. Dates back to 1935, so that this was the time when it was built. And then in the 1990s, they stopped using it and started demolition. So that's where we start. And now we go into pictures. So this is a historical picture of how things looked over there. So you see those metal structure, and then we have, of course, we have foundations over there. And because it was an exhibition area, we need a lot of parking. On the second picture, you see the parking. So this is a huge parking area, paved area with a lot of concrete. And then those are those massive foundations that you had, or that you have, under each of those metal elements, those beams. So we had the foundation. So if we go now let's think sustainable site development. And unfortunately, we can't have here a very lively discussion. I give you the story without asking you what would you do. I give you the classical story, and I give you the sustainable story. The classical story is that, of course, everybody would have taken down, or this is taken down. The concrete here is removed. The foundations are excavated and removed. So that's the classical approach, meaning we eliminate all the problems that we have on site. What is the result? We have a lot of excavation. We have a lot of transportation. We're moving the material to other locations. Okay, maybe some of the materials can be recycled, can be reused somewhere else, but also there is a lot that goes into a landfill. So overall, increased transport, increased crushing, increased landfilling, definitely not sustainable. Now we come to the clever approach, and here it's about working together. Communication is maybe this is the last subject of today's course, but I tell you now already, the secret to a successful, sustainable brownfield development project is communication. Communication within the project team and communication with other stakeholders like neighbors, authorities, the city hall, whatever. And here specifically, I'm talking about the communication between the structural engineer, the environmental engineer, and the architect. Because what the solution was here, and I like talking with my hands, so maybe I can explain it to you visually. On one side, we had the hall, the building. And on the other side, we had the parking place. Where we have the building, we have 100 foundations. where we have the parking place, we have this huge paved surface. And in order to avoid excavating all those foundations, what the decision made together between the structural engineers, the architect, the environmental engineer was, hey, let's swap sites. For the new facility, we also need parking. But in order not to remove the foundations, to do it more sustainable, let's put the future parking place on top of the old foundations. They don't disturb us. They are no environmental issue. They're just foundations in the ground. Let's keep them there. Let's put the new parking place on top. And the material from the parking place, we will reuse it as the base layer for the new parking place. Because the parking from a structural engineering perspective is very simple, so it's not a complex thing. So we can easily, we just took the material from the paving, crushed it, put it as the base layer for the parking, and all the foundations, all those 100 foundations were not touched at all. They stayed where they are. And this is where I want to get you step by step. It's this out-of-the-box thinking. Work with what the site gives you. Use the challenges and turn them into an advantage for you. This is what sustainable site development is all about. So what they did, finally, there was a lot of crushing involved from the from the paved area, but the material was not transported away. It stayed on site and became the base layer of the parking. And then on the free parking area, they built the new facility. That's the whole secret of this project. Here at the summary, you can see there was also some contamination, some PCBs, some waste oil that was disposed of. In this specific case, it was removed from site. The foundations, I just gave you the solution. So very creative solution in order to avoid transportation and make the project a lot more sustainable. The next example is, again, United States, but we're not in the north, we're not in the south, we're in the Missouri area, so the state of Missouri. The city is called St. Joseph. Maybe that rings a bell in which direction we are going here. The state of Missouri has the name from the river of Missouri. So the river Missouri. The river Missouri is like most rivers that are naturally flowing. They have floods, and the material from the riverbed is distributed over the area, sediments, and you have a very high groundwater level, and the fine sediments are not very ideal for construction. So this is the history of the site. So there is a picture that shows a little bit of the footprint of the site. So this is not very interesting, but here now it becomes interesting. This is why this example, this is one reason why this example is here in the presentation. You see here high groundwater level. This is due to the proximity of the river. The groundwater level is very high there. And what you see here in these dark layers are those sediments that I mentioned that are not very nice to build upon. So any structural engineer would say, well, high groundwater, fine, it's kind of clay material. It's like the plasticity is very high. It's not very stable. It's kind of difficult to build on. And in many projects, a decision would have been made. Let's again take the example, not sustainable. We'll say, okay, we cannot use the site, high groundwater, the soil is bad. Let's go somewhere else and let's build somewhere else. And then you see some foundations here on site, on the side here. So there is a lot of foundations also. And yeah, what is the solution? Let's start with the foundations. Again, discussion, architect, environmental engineer, structural engineer, project owner. The foundations on site, well, we don't have a problem with that. We are not building a basement. We are building a facility on surface. We don't need to go deep into the ground. So we started using the foundations, and where necessary, we cut the foundations to go through with pipes. So only in those areas where we had to go through with pipes, we cut the foundations. The rest of the foundations remained in place. So that was the solution for the foundation. Not generate, we are again at the waste pyramid. You remember, we are on top, not generating waste, avoiding waste. That's the highest priority. Reducing transportation, reducing disposal, reducing emissions from transportation, and reducing dust, reducing noise. This is all the sustainable elements that will give you points for certifications, but we're not doing this for points only, but really to have a positive impact on the environment, because we are not putting the material into a landfill. But coming back to the soil, this is so now it's a little bit difficult maybe to describe, but we will manage it together. What you see here, and I hope it's big enough on your screen, you can see here, it looks like a grid. It is a grid. It's so-called a geogrid, and it's made out of polypropylene. So what you have here, again, sorry if I will use my hands. So you have two layers of polypropylene fibers that are welded together so that it ends up in a grid. So polypropylene is a material out, it's made out of oil at the end of the day, but you can make it also made out of recycled plastic. So re-oiling is now the new trend. So, but ultimately, let's say it's a plastic, yeah, to have it simple, and you can make those thin, like a rope, and then you weld it together with heat. So what you get is a very, very strong grid. It's really, really strong. And what they did then is they put the layers like in a hamburger. They made several layers, a layer of soil, a grid, another layer of soil, a grid, another layer of soil, a grid. And what you see here is ultimately, like you use steel for reinforcement in concrete, you use this grid as reinforcement in soil. And maybe some of you come from an engineering background. What does the steel in concrete? Why do I have a combination of concrete and steel? The concrete is resisting against pressure, and the steel is resisting against strength, strain, so pulling. So I have the concrete takes the push and the metal takes the pull. This is why those two materials are working together so greatly in the combination of steel and concrete. Here we're doing something similar. The soil, because it was so soft, was not able properly to take the pulling strength. It only, so there is the pushing, but there was no force that, no material that could take the pulling. With this geogrid in this layered approach, I added an element that was capable of taking the strain, the pull, and therefore the solid became so stable that construction was easily possible on that site, although the soil itself was not so good at the beginning. An option would have been excavation, replacement of soil. Again, you have to bring new material, you have to transport off the material. So you see, it's always about what solution can I find to work with what I have on site. Another creative solution, how to overcome this problem. Yeah, and finally, this is how it looked like at the end. And in the back, you see the Missouri River. So finally, they managed to implement this project in a sustainable way and using this old site. And here we had some crushing, we had some reusing. The foundations remained in place. It was kind of, this is now repeating. Yeah, this is something you will face in many different areas and projects. So next one, we are back to Chicago. The reason why, again, Chicago, Epstein, they have their headquarters in Chicago. That's why we have the projects from Chicago as well, so many. This is an interesting project because they got a LEED Platinum certification. This is the highest certification you can get under LEED. And here is important to mention that there was some incentive from the city for redevelopment, and also a shorter permitting process for because it was a LEED project. So what you see here is a picture of where the site is located. It's an industrial area. It looked not very nice before the redevelopment. Nobody did anything over there. So the city said, we need to make it attractive to do development in this area. And that's why they came up with this idea of a land incentive. So the buyer got the land for free, the land, but had to implement a sustainable project. And this is the lake you already know. So in this case, they had to plant new trees. They put the lake over there. This is just a conceptual drawing. Green roof, wind energy, solar energy. And this is now the real world. So they put the wind turbine over there. They built the green roof. They built the solar panels. They had electrical charging. So there is many things you can do. And the contamination solution, I can't show you on the picture, but I will show you later on when we come to the remediation part, what they did over there. I can tell you what they did. They had a contamination on site, and the contamination stayed on site. It was not removed. That might sound now, without explanation, a little bit strange, but you will understand very soon why it was actually a very clever approach. So the next message I'm giving to you before we move to the remediation topic is, because we have a remediation does not mean we have to spend money on remediation. Those are two different topics. Good. Those were some practical examples from, and maybe please remember this. You can read here in the left column, lead, arsenic, and chromium. That's important for the solution they applied. This is a little spoiler alert. And now I want to give you an understanding, a very basic understanding of remediation, because this now rounds up the whole story around sustainable site development. It closes the gap, an important financial aspect that I told you at the beginning, that on a greenfield, I don't have contamination. On a brownfield, I usually have contamination. So if I need to spend money on the contamination, my brownfield project is more expensive than my greenfield project. Logical. Trick. If I don't have to spend so much money on the brownfield project, maybe it's not more expensive. Question mark. We will come to that. So, sustainable remediation. I want to give you a short introduction. Why are we doing remediation? And what happened in the past? Remediation came from areas and from countries where there is a lack of space, a lack of land. It's not a coincidence that the Netherlands are one of the leading countries worldwide when it comes to remediation. No, that's very simple explained. The Netherlands is super small. They have problems with land surface because there is a lot of water and high groundwater. They need to use every square meter they can for building. So they came up very early with the concept, hey guys, we need to do something and we have to think how to deal with remediation. That's where it started. In the United States, kind of similar, but they have more space, but still they realized it pretty fast that they have to do something. Remediation in the past was, I have a problem and I remove the problem. So I have a location here with a contamination. I take the contamination away and I put it in a landfill. That was the solution many years. And then people realized, wait a minute, we cannot pay for that. That's too expensive. Taking the material out, transporting it somewhere else and putting it in a landfill, not only is a lot of costs for taking it out and transportation, it just moves the problem from site A to site B. Yes, the landfill is maybe the better solution because it's properly designed to receive waste. But every landfill, no matter how good it is built, is a future brownfield site. Maybe not tomorrow, maybe not in 10 years, maybe not even in 50 years, but later it will be. So all the landfills we have now, if we don't do it clever, will become our future brownfield projects. So at a certain point, they realized we have to come up with a different concept. And the concept I'm showing you now is the solution to just removing the problem. We are starting with what I told you at the beginning. We have to understand what the problem is. We have to understand where it is. Thank you for the chat comment, but I can't read it. So I don't know what to reply to the chat comment. Somebody shall help me, please. Please. So what okay, so one more time, please. Okay. So okay. It's not really the subject of today's course, but can we park this for the end? And I think I can reply to it, but I would like to park it for the end. Is it okay for you? And then in the wrap-up session, we can go back to this one. Good. So here the idea is, and we really don't go into the into the depth of the technology. The point is, we are looking at different aspects. We are looking at the site itself, at the water, at the soil, and once we put everything together, it's like working in AutoCAD with several layers. we understand the building, the situation of the contamination of the problem. And this is what you should remember, because this is the key, the trick to sustainable site development. You have to understand the source pathway receptor model. What does it say? I always have a source, which is my problem, which is my contamination. In our case, it is there because we have a problem, we have a brownfield. There is a receptor, which is us. We cannot make the receptor go away because we want to build there something. And what is remaining is the pathway. And the concept is very simple. Where those three overlap, let me call it different. If the three overlap, we have a risk. If you remove one of them, if there is no source, no risk. If there is no receptor, no risk. If there is no pathway, no risk. Only if all three come together and overlap, then we have a risk. This is the basic principle you have to understand. So by eliminating one of those three, and as we said, the source, we can eliminate the source and excavate it and remove it. That would be a solution, but it's not a sustainable solution. We cannot remove the receptor because we want to do a development. But what we can do, we can work on the pathway, for example. And now coming back to the project that you saw, they covered it up. So they put a barrier between the contamination and the receptor so that there was no interaction anymore between the contamination in the ground and the receptor on top. If you do that right, you have no risk and you can keep the contamination in the ground. There are several pathways. This is also what I want to show you. You have either the direct contact. So let's assume there is this contamination in the soil. There could be the direct contact, we touch it. So if you want to build there a children's playground, not possible because they would touch the soil. If you put a barrier in between and you put a fresh soil on top, theoretically, yes, it's possible. There is another problem if the contamination goes into the water. This is what you see here on the picture, so that the contamination moves into the water. And then from the water, from the groundwater, maybe in a lake or in a sea. Or if we then take from the groundwater, we take drinking water. So there is an indirect contact to the contamination. First in the soil, then in the groundwater, and then to me when I drink it. So what we're talking about, and there is also theoretically another pathway through the air. So there are some contaminations, you see this here, from the contamination in the soil vapors through the soil into my house. So this is a gas migration. This is also a pathway. So this is through the air. And this is what we have to analyze. And how do we analyze it? We make a risk assessment. I skip that slide because it's not so important for you to read. This is what at the end of the day is important. What we assess it, how likely is it to happen? And if it happens, what are the consequences? Let me give you an example that is maybe more closer to us than a contaminated site. A flood, a river. You know, the water level in a river changes depending on the rainfall, depending on the season. And a river basin has a certain shape with a certain volume. So if the water level is above, then it starts to flood the area. That's why alongside rivers, there is a so-called protection area where you're not allowed to build. If you build there, you would be flooded more often, or the consequence would be more severe. That's why big construction is only allowed further away, that the likelihood of being flooded is lower and the consequence is minor. You understand the concept? Sometimes we cannot exclude completely the risk. There is a remaining risk. But if the flood happens every 100 years, maybe that's acceptable. If the flood happens every month, it's maybe not acceptable. So the difference here is when we are developing brownfield, we have always this risk assessment, and we are deciding, is the consequence acceptable, or is the risk acceptable, or is it not acceptable? How often does it happen, and how severe is the problem? I give you a practical example, but without pictures. I was personally involved in supervising a remediation project in Bucharest. It was an old, so we did not do the design, but we were responsible for the supervision that it is executed properly. It was a former site where a deposit for oil and fuel. It was ugly, it was stinky, it was bombarded in the First and Second World War. There was a huge pollution in the soil and in the groundwater. It was stinking in the area. It was horrible. And finally, they decided to do a cleanup. And between the authorities and the developer, there was an agreement on what is the level of cleanup required. It was not said remove everything, because this is even technically not possible. So there was always a remaining small pollution maybe in the soil or in the groundwater, but so small that the risk is so low that it was acceptable. On top of the remediated site, there is now a school and a kindergarten on that formerly polluted, heavily polluted site. And because the parents and the teachers were worried that there is still some residual contamination in the ground, they were worried about building the school and the kindergarten over there. I said, don't worry, guys. Although I personally don't believe that it is a risk for you, I understand your concerns. Let's implement an additional measure when we construct the school and the kindergarten that protects everybody. So what we did is we implemented a drainage layer under the building for potential vapors from the residual contamination. You know, it can be very warm in summer, and when it is warm, as we have it with the tar, but some volatile substances might go up in the soil. Those vapors that we saw on the other picture. So in order to capture those vapors, we had these drainage layers with some pipes and with under pressure. So we were actually sucking permanently, or when necessary, you can turn it on and off, the gases out of the layer, so that there is no migration of gases into the building. And this works perfectly fine. Everybody was happy with the solution. And now, since I think it's already 3 years, they have the new school up and running, and the kindergarten, there is no smell, there is no problem. So it is working. You just have to deal with concerns, with risks, with likelihoods, with consequences. It's possible. Good. We have 2 more chapters. Oh, we have another half an hour. That's perfect. Those you don't have to remember really, but they explain you certain of the examples I gave to you. So I just want you to understand them briefly. So this is the non-sustainable way of doing it. You have an excavation, a polluted area in the soil. So there is some pollution in the soil. As you can see here, it's not going into the groundwater, it's above the groundwater. And what you do is you replace the contamination with the clean soil. Well, very simple, very fast, usually depending on the size, but usually fast compared to other technologies. And it's called dig and dump. That's the classical historical approach of solving problems. It's not the most sustainable one. In some cases, it's still important to use it, because if there is a risk that this pollution can go into the groundwater, so it's very mobile and it could be transported in the groundwater, then we might have to remove the contamination. And this example that you had from the United States with arsenic, with chromium, with lead, this could stay in the ground because heavy metals are very stable products, compounds. You cannot leach them. Yeah, they are in the ground. They are very, very stable. So there was no risk of groundwater pollution. They said, okay, let's keep them in the soil and let's cover them up. And I show you, I'm jumping a little bit now. Sorry, this one here. So, no, this one here. But there is one missing. This is strange. Yeah. So this is where you have the pollution, and then on top you put a cap. This is the one on the right side, which avoids rainwater from going into the contamination. And now let's combine our thinking from before. Even an asphalt or a concrete can be impermeable. So if I have a contamination, I can theoretically either build the parking lot on top of it, or I can even build the building on top of it. So putting the building on the contamination or the parking lot is already a remediation solution. So now you see how those things all fall together. And this is why it is so important that you do the investigation first, that you understand your problems, and then decide with the architect, hey, over there I have the pollution. Do you mind if we swap the design and put the building over there or the parking lot over there to cover up the pollution? So this is why all those disciplines have to work together in order to make it a sustainable project. And sustainable does not mean just saving money. Sustainable means here also protecting the environment and protecting the people. So all those elements have to go together. If the risk assessment says the risk is too high, then okay, we might have to use a different treatment approach. We cannot keep it on site. So it's not that I'm telling you always keep the contamination where it is. I'm just telling you there are so many different solutions, and you need to understand the big picture to decide what is possible and what is not possible. So here, this is just for information. Sometimes it's even enough to work on the air. So in this specific technique, the contamination remains in the ground. And what you do is you extract air from the ground in order to reduce the contamination. Or you can also inject air. So you can blow in air in the ground, and at the same time, you suck out air of the ground. And if this is, for example, I don't know, benzene or diesel, there are some volatile compounds, and you can easily remove them from the soil. Something similar we did for this school in Bucharest. The example I gave to you, a very, very similar approach we used over there. It was not really necessary, but to make the developer more comfortable, we did it. And he had no problem because it was little extra costs, and it gave him the level of confidence, and more important, the parents a level of more confidence that they were then willing to send their children to this school, although it has been constructed on a formerly polluted land. This is a technology when the contamination is in or on the groundwater. So this is also possible. So even if you have contamination in the water, you can remove it. Those technologies usually use more time. And it's very important here as a project developer to understand how does it impact my development plans time-wise? Where can I already build and where can I not build because I need to work on the remediation? And again, this project in Bucharest is a good example. What I need for this is I need somewhere, as you can see here, the green thing is a well, is a groundwater well where I extract the pollution. And then somewhere I need a facility where I can treat the pollution. So on site somewhere, I need a place for the treatment facility, and on site somewhere, I need those places where I can extract the pollution from the ground. With an experienced environmental engineer, you can even do your construction, your development in parallel. It's again a matter of communication. We had cases where we did some extraction in the basement of an existing building. So it is possible. It just requires discussion, communication, finding solutions together. This we already had. And the last one is, this is about a permeable barrier. This is where there is a wall in the groundwater. The contaminated groundwater is flying from one side, passes through the wall. The contamination stays in the wall, and the clean water continues flowing on the other side. The wall in between is nothing else than a material that is able to absorb the contamination from the groundwater. So you have the problem sticks to the wall, the water continues flowing. This is all you have to know. Let's skip this part now. We're coming to the last part, and we already had it. Why it's not doing what it should? It's about the communication, and this is a funny game with letters. You can read it if you're in the mood. The nutshell, the bottom line is, and this is better here shown, it's a matter of talking to each other. It's a matter of partnership. It's a matter of transparency, talking to the people involved right from the beginning. I can tell you there are many remediation projects, brownfield development projects out there. The ones that are most successful are the ones where there was open communication from the start, where the people that should use or live on that site later on have been involved in the process from the beginning. Like the parents at the school. They only were willing to send the children there because they were involved in the process. They felt comfortable. If you confront them at the end, you maybe have you have a kindergarten and a school and nobody's sending the children over there because they're all scared. That would have been the negative way of doing it. So what you see here in this pyramid, half pyramid, is at the bottom is always this communication, dialogue, understanding, and it's so important to together to create a vision and ideas and define how we do it together. The planning, the building, the maintenance, of course, the public is not so much involved in that anymore. But at the beginning, it's all about transparency, transparency, transparency. Then your project can be super successful. That's the message you should take with you. And everybody knows, or most likely everybody knows about public-private partnership. And this is when it turns into a 4P project. It's actually public-private people partnership. And it's not so much about just the public and a private investor. It's the people that make it a success or a failure. And this you have also visualized here. So there is an element where you have also the external stakeholders involved. And of course, there is other things that is more or less internal. So you should use for all your projects these 4P approach, because that's the one that leads usually to success. Of course, it's not a guarantee, but the likelihood is so much bigger than doing it secretly and then confronting people at the end. Because then they always think, oh, you want to hide from me something. I don't trust you. You didn't tell me from the beginning. So what's the conclusion? What do I want you to take with you? Of course, you make the choice what you like best and what was most interesting for you. But this diagram to me is very important because it summarizes what we discussed today. Usually, the land costs more in a greenfield because it's a greenfield, and you can get it for a cheaper price when it is a brownfield. But on the other hand, you have costs for remediation. This is this reddish part. If you do a classic remediation, the remediation costs can be very high. If you do a sustainable remediation, you can cut the remediation costs a lot, or even eliminate them completely. Additional costs you have at the greenfield is the infrastructure. And here we have a little discrepancy. Sometimes the brownfield sites can even be more expensive from a land perspective because they are in the middle of the city, and inner city land is more expensive usually than outer city land. So on the land side, maybe the diagram is not 100% correct, but the message I want to give to you, when you go with a brownfield in the urban area, all the infrastructure costs, you don't have to spend. You have the roads there, you have electricity there, you have gas there, you have water, you have sewer. That's a big investment in a project. If you go in a greenfield at the border of the city, over there, the urban development did not take place yet. So you might have to invest in the road, in the water, in the gas, in the electricity, you name it. And the social aspect is to be added as a cost aspect in the greenfield development, because we already had that. If I'm inside the city, public transport, more walking, healthier, there is the social cost. So the message, bottom line is, compare apples with apples and not apples with pears. Make it a fair comparison. Add all the elements that need to be brought to the discussion. Not just, yeah, the building is cheaper here because I don't have to do remediation. Yeah, maybe you don't have to do remediation, but in a brownfield, maybe I also don't have to do remediation. But I improve the environmental situation on the site a lot. So this is one of the main messages I want to give to you. The second part is, as you can see here, investigation, investigation, investigation. This is what it is all about. That's the key to success. You take the time for the design, think out of the box, talk to somebody who is experienced, and use what you have. Don't consider everything a problem. Consider it also as an opportunity that you can use in your advantage. Just be creative, be creative. And we talked a lot about why is it complicated to do a brownfield project. This is the last slide, and I really want to close it positively. There is so much positive impact when you do a brownfield redevelopment. We discussed all of this. You can read it one more time. I hope I could give you some ideas, a spark that could start a fire or create a snowball effect, if you like that one better. I personally believe and experience that this is the right way to go. This is definitely the sustainable way to go. It still requires a lot of convincing, training of people. And if you need my support, you can reach out anytime to me. On the last slide, you find my contact details. Just call me, send an email, please, in English. And I'm willing to help you. And now we have another almost 15 minutes so that I can answer to your questions. We have one part from before, and then there are 2 more now. So let me scroll up to the one that was parked. So it was about the energy saving technologies for new construction in the Ukraine. You saw some examples. I personally believe that you should start generating as much energy as part of your project. It could be solar, it could be wind, it could be geothermal, depending on where you are. So if you decide to develop a project, think also how can I be as independent as possible with my project? Water is a big subject. So here you can save a lot of costs with doing your water regeneration, your water management on site. There are cool technologies that help you to create a more comfortable indoor air, like the clay walls, or even in bathrooms it works very well, some vegetation on the wall to have a kind of more comfortable indoor air climate. So that's not so much this is all energy saving. Also the repair of a clay wall is so much simpler than any other wall. But I'm not banning concrete. Concrete properly used in a building can be extremely energy saving. If you have a big monoblock of concrete that you incorporate in your house, it stores energy, and it also helps to regulate the climate in the building. So it's not that concrete is bad. It's just that you have to combine the materials in the best way possible. I hope that answers a little bit your question and gives you some inspiration. So the other 2 comments, I need please a translation, because otherwise I cannot answer them.
Perhaps before we move to the other questions, I could just quickly jump in and add that even though we are still finalizing the way how we are going to support the certification in Ukraine with our Ukraine partners, we do have experts and time of our experts in the Smarter for Finance for EU project. So going forward, should you want to have a specific advice for a specific projects you are planning, you can also just get in touch with me or Volodymyr from the Association of Energy Efficient Cities of Ukraine, and in the upcoming months, I'm sure we will be also able to find maybe the potential experts within our member organizations who would be able to give you a little bit more targeted advice and use the time these experts have in our projects to support your plans. Thanks. Yeah, and now to the other questions.
Yeah, there are 2 more. So please, somebody help me with those 2. Okay. Yeah, so all you saw today, all the slides you will receive. I already provided it to Eva, and I think Eva will take care of circulation and the recording. I think I don't have anything against. If there is nobody else who has some GDPR related concerns, yeah, I'm happy to share. I hope so. Maybe you can give me 1 or 2 feedbacks, either visual. I hope you enjoyed the 3 hours together. I hope there is something that you can take with you. Maybe you felt I'm pretty passionate about the subject, and I always like to kind of give that passion to other people to build on that and grow the spirit, the idea in your area of influence. So thank you very much for listening, and I'm still here for, if you want, answering, hearing feedback.
Thank you, Martin. Yeah, and I must say that I'm a big fan of this Grand Designs BBC series, and this was as inviting and amusing as this series. So well done. Like all those examples, all those pictures. It was a really great way how to get a bit more excited and think out of the box about the building site. So well done, and we'll be happy to share the recording if anyone would not prefer to share. Feel free to send me an email and flag me that you do not feel comfortable with sharing the recording. That's perfectly okay. If I won't receive any emails, I will send it to everyone. So thank you, and don't forget that going into the next week, we will also have presentations, courses on the 23rd and 28th of November, at the same time as today. So please join us for the upcoming presentations. There should be most likely another one in December, but I will inform you in due course. Thank you also to the translators, and I think that's it. I'm just checking that the comments. Yeah, the examples are really very well. Yeah, I read in the comments. So thanks again, everyone, and that's it for today.
Thank you to all of you. Have a great day, and let me know when you need help. Thank you. Bye.